T11.7 and T11.8. A researcher wished to compare the average amount of time spent in extracurricular activities by high school students in a suburban school district with the average time spent by students in a large city school district. The researcher obtained an SRS of 60 high school students in a large suburban school district and found the mean time spent in extracurricular activities per week to be 6 hours with a standard deviation of 3 hours. Okay, so let's jot some things down. So x bar 1 is 6, S1 equals 3, sample size is 60. All right, the researcher also obtained an independent SRS of 40 high school students in a large city school district and found the mean time spent in extracurricular activities per week to be 5 hours with a standard deviation of 2 hours. All right, so x bar 2 is 5, S2 is 2 hours, sample size is 40. All right, suppose that the researcher decides to carry out a significance test of, okay, so that says null hypothesis, mu suburban equals mu city. In other words, the true means of the two regions are the same, versus a two-sided alternative. So a two-sided alternative would be HA mu suburban not equal to mu city. All right, T11.7, which is the correct standardized test statistic? All right, so a standardized test statistic is a statistic minus a parameter divided by an SD. Let's call this a standardized test statistic. Okay, that's the general formula. And the specific formula is going to be, because this is means, we'll get a t-score. The statistic will be x bar 1 minus x bar 2. It's a difference in the sample means, minus mu 1 minus mu 2, the parameter, divided by square root S1 squared over N1 plus S2 squared over N2. Okay, so all of these expressions, this one, and that one, can be found on the formula sheet. Okay. All right, so looking at the answer choices, I'm going to start eliminating some since they don't kind of follow this structure, right? So I'm going to eliminate A. I notice that these aren't being squared here. Same thing with D. Okay, we're going to eliminate B because it says Z, and it should be a t-score. And we could eliminate C because, again, it doesn't follow the structure there in the denominator. So E is going to be the correct answer, right? We didn't have to do that much work there, just kind of look at the structure. All right, T11.8. The p-value for the test is 0.048. A correct conclusion is 2. Okay. So choice A, fail to reject HO because 0.048 is less than alpha, 0.05. Okay, so already I can tell you that's wrong because if the p-value was less than the significance level, we would reject, not fail to reject. Okay, so for the same reason, we could eliminate B and we could eliminate C. Right, at the 5% significance level, we should be rejecting the null hypothesis since the p-value is less. All right, so that leaves us with two choices now. D says reject the null hypothesis because 0.048 is less than 5%. There is not convincing evidence of a difference in the average time spent on extracurricular activities by students. No, that's wrong. There is convincing evidence, right? The result is statistically significant, right? We've rejected the null hypothesis, which means, right, if we're rejecting the null hypothesis, then we have convincing evidence for the alternative. The alternative says that there's a difference, that they're not equal. All right, so D sounds incorrect to me. E, reject the null hypothesis, 0.048 is less than 5%. There is convincing evidence of a difference in the average time spent on extracurricular activities by students in the suburban and city school districts. All right, that's the correct conclusion.